This is a tutorial on drawing shear and moment diagrams. We have a simply supported beam here with a point load of 100 kips and a moment of 300 kip feet acting at a distance of 4 feet from the right support. The beam is 12 feet in length overall, and on the right hand side of the screen is shown the positive sign convention. So if you cut a beam and if you have a shear force going up to the left of the cut, that's a positive shear force, and a shear force going down to the right of the cut is a positive shear force. And the sign conventions for the moments both clockwise and counterclockwise are also shown. Okay, so the first step in drawing shear and moment diagrams of such a beam is to find out the support reactions. We can do that fairly easily. Let's call support A here on the left and support B on the right. And if you take moments about B, you will know that RA times 12, reaction of A times 12, that's a clockwise moment, plus 300, that also is a clockwise moment, will be equal to 100 times 8, which is a counterclockwise moment. So reaction at A, we can solve it as 41.67 kips, and reaction at B you will know as 58.33 kips, just from sigma Fy is equal to 0. Okay, now knowing the reactions, what's the next step? We have to start drawing the bending moment and shear force diagram. So let's start with drawing the shear force diagram for this beam. It's a good practice to actually mark all the critical points that you have so that you can figure out where the shear and moments are changing. And let's do the shear force. That's positive, that's negative for shear force. Okay, so let's do the free body diagram for this beam. Let's take a cut immediately to the right of the support A. So you have a support A, take a cut immediately. The reaction at A, you have found out it's 41.67 acting up, and therefore there has to be an internal shear of 41.67 to the right of the cut acting down. That's positive as far as the sign convention is concerned. So the first point in your shear force diagram is going to be a 41.67 kips, which is positive. So here you can mark 41.67 positive. That's a first point in your shear force diagram. Moving to the right, now there is a 100 kip load at a distance of 4 feet from that support. So if you go just to the right of that load, then you will have a 100 kip load that's acting down. Therefore, to counteract that, there has to be now 58.33 kip that has to be acting up. Acting up to the right of the cut is negative, so you have 58.33 kips negative here in your shear force diagram. Because there is nothing happening between A and the point load, you can do that. Then you can do this. Now this is a fairly straightforward and easy shear force diagram, because from the loading you can see that beyond that 100 kip load there is no forces acting. Therefore you can take your shear force diagram, all the way down like that at 58.33 negative. That is your shear force diagram. You can also check this from the right side of the beam by taking a cut here, section B. So you know from the reaction there is a 58.33 kips that is acting up. Therefore, the internal shear to the left of the cut should be a 58.33 acting down. Left of the cut acting down is negative as far as the sign convention is concerned. Therefore, you get 58.33. You confirm your shear force diagram. So that's a simple, straightforward shear force diagram. Bending moments, we can consider bending moments to be the area under the shear force, and then basically go from left to right as we do. So extend this down to draw the bending moment diagram. You can come all the way down here. Okay. Now the area on the first part of the beam, it's 41.67. This value was 41.67. So this area is 41.67 times 4. That is 166.7. So this is, so here the bending moment is 0. It has to change because the shear force is in the positive zone. It has to change by 166.7 kip foot. Therefore, we go here. That is 166.67 kip foot. That's bending moment, positive, negative. 166.67 kip foot moment. Now, if you take the next part, here it'll be the area of this section, this rectangle here would be 58.33 times 4. Remember, so that's going to be negative, or the bending moment is now going to be changing down or reducing. 58.33 times 4, that's 233.3. So from 166.67, you drop down 233.3 by the time you get here. So 166.67 minus 233.3, you will get a value of 66.6. So come here all the way down to 66.6 here. Now remember, that part has a moment of 300 kip foot acting here, right? You have a 300 kip foot moment acting there. Therefore, you get to that 300 kip foot, which means you have 66.6 here, and you need a 233.3 going here. That's 233.3, so that the total moment at that point will be 300. Magnitude of the total moment is 300 at that point. So 233.3 kip foot. Because you have 66 here and then 233.3. Now this part, again the area is 58.33 times 4, which is 233.33. That's negative, so now the moment will have to drop down negative. So 233.3, you will come all the way to 0. And that's what you want, because for that support, the moment has to be 0. So this is your bending moment diagram. So you have your shear force diagram, you have a bending moment diagram. Again, we did not do too many cuts for shear force diagram. We just did one cut and then kept on adding loads on that as you progressively move from the left to the right of the beam. And in further examples that I'll show, we'll use a similar method, and we'll show how this method can be used for other examples also. So this is a simple shear force and bending moment diagram a relatively simple beam and loading conditions.